Hello everybody, welcome back. Today we are looking at session 10. We want to look at using views, stored procedures, and querying metadata or metadata. We start by looking at the objectives. Now at the end of this session, you're going to define what is a view, describe the technique to create, alter, and drop views. We are going to define stored procedures, explain the type of stored procedures or types of stored procedures, describe the procedure to create, alter, and execute stored procedures. We are going to describe nested stored procedures, describe querying SQL Server metadata. We are going to look at the system, catalog, views, and function, and also dynamic management objects. Let's get started. Introduction. An SQL Server database has two main categories of objects. We have those objects which store data, and those objects which access, manipulate, and provide access to the data. And this is the most important. After all, we are providing the database as a backend store to our data. We have the views and stored procedures which belong to the second category, that is objects which are used to access, manipulate, or provide access to data. A view. Now, what is this thing we're calling a view? Now, a view is a virtual table made up of selected columns from one or more tables, and the tables from which the view is created are referred to as the base table, and the base tables can be from different databases. Now, a view can also include columns from other views created in the same or a different database, and a view can have a maximum of 1024 columns. The data inside the view comes from base tables that are referenced in the view definition, and the rows and columns of views are created dynamically when the view is referenced. Creating views. How do we create views? Now, a view is created using the create view statement, and it can be created only in the current database. And a user can create views using columns from tables or other views only if the user has permission to access the tables and the views, and also if they have the create view permission. SQL Server verifies the existence of the objects which are referenced in the view definition, and the syntax used to create a view is given below. You write create view, you give us the name of the view you would like to create, and then you give us the SQL statements that are referenced by that particular view. Now, the following code snippet creates a view from the product table to display only the product ID, the product number, name, and safety stock level of products. Okay, we are going to do this, but before we do this, we have a small exercise that I would like you to do. I'll switch over to Notepad, open the solution we've been using. Then in the solution explorer under scripts, you create a new script and you give it this particular name. Okay, once you do that, we come back and continue. Okay, all done. You make sure you write the purpose of what you are going to be learning in this particular session. Now, this usually helps you when you're revising. Okay, the first thing we want to do is to switch to our customer database. Okay, we highlight this statement and execute it. And now we're in the customer database. Then we can go back to your slides. So we're going to copy this and then we paste it. So do that very quickly. Let's meet in the query window. Okay, all done. We have created this view, and the purpose is given here. There are some adjustments I have made. Number one, you have to use the fully qualified name. Remember, we are working in the CastDB, but these details are found in the AdventureWorks 2016 database. And remember, we have also said that the views can get data from different tables in different databases. Okay, we can then now highlight and execute this set of statements. You click on execute, and the view is created. To display the details in a view, you basically do the same thing. Remember, it's a virtual table. Therefore, the select statement is going to give you all the details that are returned by that particular view. Okay. Now, as you can see here, I have this statement that is going to get the details that are returned by this view. And once I highlight this and execute it, then you can see it gives you this particular set of details which are found in this particular table in this schema in this particular database. Okay, so this is what we have, and you can see the results as what we had in our in the query window. Now, creating views using the join keyword. You remember we learned this in the previous session, that is session 9, and the join keyword can also be used to create views. The create view statement is used along with the join keyword to create a view using columns from multiple tables. The syntax used to create a view with the join keyword is given below. You will write create view, you give us the name of the view as select, then the statements from which you want to, the SQL statement that you want to execute to give us the actual details of that particular view. Okay, and this is explained here. View name specifies the name of the view, table name 1 specifies the name of the first table, join specifies the two tables are joined using the join keyword, table name 2 specifies the name of the second table. The following code snippet creates a view named VW person details with specific columns from the person and employee tables, and the join and on keywords join the two tables based on the business entity column. Okay, we highlight this, copy, and let us meet in the query window. Okay, all done. The purpose of these statements is given in line 17. We are going to highlight, and you can terminate this with a semicolon, it's optional, or you can write go. Highlight this, click on execute. The view is created, and if you want to display the records, we are just going to make a few modifications to this. Just highlight this very quickly, right click and select copy, come down here, then paste. We want now to display the contents of the person details view. Change this as well. I'll use the IntelliSense to assist me, or code assist. Press tab for autocomplete. Then now we save our work. Okay, and to view where your views are stored in your database, in your Object Explorer, under the databases node, expand it, go to your database, then expand the views node, and you can see our two views are displayed here. Okay, then now we can execute this statement, and you can see what it gives you. Now here, this particular query that we are looking at is giving us the personal details. And as a small challenge, let me write something that you can try out. Your challenge is here in line 33. We want to also return the employee's gender and age. Okay, and we are going to look at the base tables that are giving us these particular details. The first one is the HR schema. We look at the employee table in the HR schema. We have the person table in the person schema. Let's start by looking at the employee table. We expand the AdventureWorks node, go to tables, we have HR, then the employee table. We want to look at the columns. Now the columns are given here, and if you look at this, we don't have the column for age, but we do have the column for birth date. We can do a calculation, which is going to give us the age, and we do have the gender here, so that one will be pretty straightforward. I want you to find out how you can go about this and write your answer here. It's good to practice these things. I'll give you a hint. You can use the dateDiff function, or you can use the year function, and they'll basically give you the same results. Okay, so pause here, do that challenge, then we can move on. Okay, this is a possible solution. Remember, in programming, we said that there are so many ways to do one thing. Now, we are going to highlight this, and then we create this view, click on execute, and it's actually created. Now we want to see the details returned by this particular view. Once you click on execute, you can see what it gives you. We have the employees' names, their age, gender, and their job titles. This is what usually happens when you are querying data from the database. And these are the queries which you're going to write in either Java or any other programming languages that we'll be covering in subsequent semesters. Okay, we move right along. So you can see what it is that we had once we executed the previous query. Now, as shown in the figure, all the rows may not have values for title or middle name columns. Some may have null in them. A person seeing this output may not be able to comprehend the meaning of null values. And to resolve that, we can actually use a function called coalesce. Okay? The following code replaces all the null values in the output with a null string using the coalesce function. Now we are going to copy this as well, and it's the same statement, but with modifications made. Okay, highlight this, copy, let's meet in the query window. Done. Now let's look at this. We have made a small change. Instead of now person, this we are calling it personal details. Okay, be careful to note this. And we have changed this and preceded the titles with coalesce, where in case it's null, we replace it with an empty string. Okay, highlight this, then execute it. You can display the records from this particular view by writing the select statement. This is the statement that we are going to use to display the records returned by this particular view. Highlight line 60 and you execute it, okay, to give you the results. Now you can see that where we had nulls, they actually replaced. If you want to see a good comparison, you can actually execute the two. Let's execute the previous one, then we execute this other one. Okay, I've just copy pasted the previous query we had so that we can compare and see the difference between the two. We have this execute, and you can see now this one has nulls, while these other ones, if you highlight and execute it, now removes the null. So all those values which were left blank are just displayed as blank, courtesy of the coalesce function. We save our work and move right along. Okay, this is the output we got, and we move on to guidelines and restrictions on using views. Now, before creating a view, the following guidelines and restrictions should be considered. A view can be created using the create view command. View names must be unique and cannot be the same as the table names in the schema. A view cannot be created on temporary tables. A view cannot have a full text index. A view cannot contain the default definition. A view statement can include the order by clause only when you use the top keyword. Views cannot reference more than 1024 columns, and create view statement cannot include the into keyword. The create view statement cannot be combined with other TSQL statements in a single batch. Okay. The following code snippet uses the code given earlier with an order by clause. We are going to highlight this and copy, and now notice the name is sorted person details. Okay, copy this and let's meet in the query window. You notice it's actually the same. The only difference is that we've added order by p dot last name. Highlight, then execute this bunch of statements. Highlight, then execute the statements, and this is created successfully. You can display the contents by using a select statement. Okay, so this is going to display the contents of the sorted person's details view. Highlight it, then execute, and you can see the details given here. And notice now they are sorted by the last name. You can see we have Abbas, Abercrombie, and all the other employees given here. We move right along, and you can change this. This is display the sorted contents. Okay. Let's move on, save your work. Inserting with views. Now the insert statement is used to add new rows to a table or a view, and the value of the column is automatically provided. You remember these conditions, we talked about them in session 7 when we covered tables. If the column has an identity property, the column has a default value specified, the column has a timestamp, data type, the column takes null values, the column is a computed column. Now, while using the insert statement on a view, if any rules are violated, then the record will not be inserted. In the following example, when data is inserted through the view, the insertion does not take place as the view is created from two base tables. First, we're going to create the employee personal details table with these statements given here. After that, we are going to create the employee salary details table using this code given here. After we create these two tables, we are actually going to create a view based on those two tables. These are the statements which are actually going to create that particular view, and then we'll try to insert into that particular view these particular values. Now, what we are going to do is we start with this. You highlight this, then copy, paste in the query window. You highlight this, copy and paste in the query window. Then you can actually also do this and finally have this. Then we're going to execute them one by one. Do that very quickly and let us meet in the query window. Now we have done this. I've written the statement of the first two batches, the one which is going to create the employee personal details table and the employee salary details table. You can write this if you want to create a foreign key, provided that this was defined as a primary key, okay? But it's optional, you don't have to do it. I'll execute these two as a single batch, then click on execute. The commands completed successfully. We scroll down, we then go ahead and create the view, highlight, then we execute. The view is created. You can check whether there are any records. Currently, it's not going to give you anything because we've not inserted any records into either of the tables. Then finally, we have that statement which was trying to insert the details of Jack Wilson. And you can see I've written a comment here. This is not going to work. We highlight this, then click on execute, and you can see the view or function, it gives us the name, that is VW employee salary details, is not updatable because the modification affects multiple base tables. Now question, what about if you wanted to do this using to insert values into a table using a view? How would you go about it? Let's see. First of all, let's save our work. Okay. Then I'll type in some statements which are going to be used for that particular purpose. Okay. Now you can pause the video here, then you enter these details exactly the way they are. This one is going to create a view called VW emp details. We highlight it, then execute. The commands completed successfully. We scroll down, then now insert using this particular view that we have created. We highlight this, then click on the execute button. It tells us that one row is affected and we want to confirm whether we have any details in that. We highlight the last statement and click on execute, and we can see the details for Jack Wilson are actually inserted. Okay, we move right along. Now, values can be inserted into a user-defined data type columns by specifying a value of the user-defined data type and calling a user-defined function that returns a value of the user-defined type. The following rules and guidelines must be followed when using an insert statement. The insert statement must specify the values for all the columns in a view in the underlying table that do not allow null values and have no default definitions. Where there is a self-join with the same view or base table, the insert statement does not work. Okay. The following code snippet creates a view, VW emp details, using the employee's personal details table. We are going to do this, highlight, copy, and let us meet in the query window. Now make sure you add a 2 after this. We already have this view created. It's the previous one that we created here. This one, just call it VW emp details 2. To execute it, you just highlight, then you click on the execute button. This creates the view. Then now we can try to insert. Notice that this does not work, and you can see the error message given here. Cannot insert the value null into column emp ID table, and it gives us the name of the table, and it tells us that it does not allow nulls, and it tells us the insert fails. The statement has been terminated. Okay. Now there are various reasons why this has failed. The one they're giving us in your slides is because we tried to do what? The last name column does not specify what? Does not allow nulls. Or we are saying that the insert fails because the last name column from the base table does not allow null values, and even the one for the employee ID. Okay. Updating with views. The update statement can be used to change the data in a view, and updating a view also updates the underlying table. The following code snippet creates a table named product details. Highlight this and let's meet in the query window. Highlight, then we execute, and the table is created for us successfully. If you look at your slides, you can attempt this as an exercise. You can write an insert into product details, then you insert these records. Okay, do that very quickly, then we continue. Now I've already done that, and what I want to do now is to display the records in the product details table. I've hidden the statements. Remember, we said that is an exercise. Just want to show you that the table already contains the details. Okay, we have the select statement here. I've already highlighted. I'm just going to execute this, and you can see now the details are already in that particular table. Okay, if you don't remember, you can go back to session 7 and see how we add details into a table. Okay, we save our work. The next thing we're supposed to do is to create a view. Highlight this set of statements, copy them, and let's meet in the query window. Okay, all done. We highlight, then we execute this, and we can see what the view is going to give us based on the records which were there. Basically gives us the same as executing a select star from the product details table. Okay, the next thing we want to do is to update using this particular command, and we want to change the prices of all DVD writers. The current values are 2250, 1250, and 1250. We want to change all these to 3000. Now let's do this very quickly. Highlight this, copy, let's meet in the query window. Now you can see what it is that we have currently. I'm going to execute this statement now, and then we are going to run the above statement to confirm whether the records will be updated. Highlight, then click on execute. Then now you can execute this statement, and you can see that we have been successfully able to update the records. Now please note that these are usually updated in the base table, and if we just go up a little bit and now execute this particular statement, you can see that it gives us the same results. The rates of the DVD writers has been updated. We move right on. Now, large data types include varchar or varchar max, nvarchar or nvarchar max, and var binary max. To update data having large value data types, the .write clause is used. The .write clause specifies that a section of the value in a column is to be modified. The .write clause cannot be used to update null value in a column. Also, it cannot be used to set a column value to null. Kindly note these two statements. Okay. The syntax of using the .write clause is given below. Column name, .write expression, then the offset, and then the length. Now, The column name specifies the name of the large value data type column. Expression specifies the value that we want to change and add it into the column. Offset basically is telling us where we want to start making the changes from. Then length is specifying how many characters we would like to change. Okay. The offset and length are specified in bytes for var binary and varchar data types, and in characters for and varchar data type. Okay, let's do this very quickly. We are not going to execute this exactly the way it is. If you just look ahead, you can see what it is that we have here. Okay, we don't have these details in the product details table. You can write an insert statement to add records. Now let me guide you on what it is that we are going to do so that we get the expected results. Okay, you can see that we have added the description column, and this was not there in the original description which we were given. So let's do this step by step. Switch to the query window. Now this is what you're going to do, and we are starting from line 177. Okay, the first thing we're going to do is to modify the product details table by adding that description column. These are the statements to go about it, and notice I've explained why we are putting this in square brackets. Highlight this, then execute this statement. Okay, then the next thing you do is to add more records into the product details table. These are the statements you're going to execute to insert these records in your slides into the product details table. Highlight, then execute this set of statements. Then you display the contents of the product details table by executing this statement. Okay, the records which we had earlier, we didn't have a description. Okay, that is why they're giving you none. Then finally, we want now to alter the product details view so that now it can also display the description column. Highlight this, then execute, and this modifies the product details view. Okay. Now we go back to your slides, and we can then highlight this and copy so that we can make the changes. So please highlight this, copy, and let's meet in the query window. Now, before we execute this, I would like to show you something. We can execute this statement once again, the one to display the contents of the product details table. Okay, and we are seeing that the portable hard disks are given us internal. Actually, they're usually external drives. Okay, that is why we are writing this query. We want to correct the description of portable hard drives from internal to external hard drives. Okay, and to do this, we are going to replace where we have portable hard disks. You replace the IN. Okay, see, we are starting at position 0, which is the offset. Then length, which is given by 2, we are replacing 2 characters. Okay, we replace the IN, this IN here, with EX. Let's highlight this. Okay, then we execute it. The changes are made, and if now we execute this particular statement, you can see now that the changes are reflected in the base table. Okay, we move right along. Now, deleting with views. Rows can be deleted from the view using the delete statement. When rows are deleted from a view, corresponding rows are deleted from the base table. For example, consider a view VW cast details that lists the account information of different customer. When a customer closes the account, the details of this customer need to be deleted, and the syntax used to delete data from a view is given below. Delete from, you give us the name of the view, and then you give us the search condition. Assume that a table named customer details in a view VW cast details based on this particular table is created. The following code snippet is used to delete the record from VW cast details that where the customer ID is C004. So this is the statement that is usually given, and we have the logic of deleting using views. Okay. Now we don't have this customer details table, and the view, you could attempt this as an exercise and see whether you get the same results as what is happening here. Let's move on. Altering views. Now, besides modifying the data within a view, users can also modify the definition of a view, and a view can be modified or altered by dropping and recreating it or executing the alter view statement. The alter view statement modifies an existing view without having to reorganize its permissions and other properties, meaning that it is easier for you to alter rather than to drop and recreate it. An alter view can be applied to indexed views. However, it unconditionally drops all the indexes on the view. Views are often altered when a user requests for additional information or makes changes in the underlying table definition. Now, the syntax used for alter view is given below. Alter view, then the name of the view you want to change, and then the select statements. Let's see an example here. The following code snippet alters the view VW product info to include the reorder point column. Okay. Now highlight this, copy, and let us meet in the query window. The purpose of this is given below. We had already changed a view, you remember previously. We are going to highlight, and then after we highlight, we click on execute, and this basically makes the changes. We move right along. Dropping views. Now, a view can be removed from the database using the drop view statement. And when a view is dropped, the data in the base table remains unaffected. The definition of the view and other information associated with the view is deleted from the system catalog. All permissions for the view are also deleted, and the syntax to drop a view is given below. Syntax, drop view, then the name of the view you want to delete. And we have this statement here. So I'll show you what to do. We are not going to delete this one. We are going to create one that we are going to delete. Okay. Now, what you're going to do, take these statements above here, then copy them. Okay. Then change the name. Instead of VW product info, you just change this to VW to delete. We'll execute this. The view is created. Then now you can actually delete this with peace of mind, and that particular view is created. Now let me just show you what usually happens once we create a view. If I execute this, come back to views. Okay, views is found just below your tables in your database. I'll refresh this so that we can see all the views we've created so far. You can see your view to delete is up here, and once we execute the drop view statement, execute this, then we come back here and refresh, you notice that that view has been deleted. We move right on. Definition of a view. Now the definition of a view helps us to understand how its data is derived from the source or base tables, and the SP help text stored procedure displays the view related information when the name of the view is given as its parameter. The syntax used to view the definition information of a view is given below. You write SP help text, then the name of the view. Now I'm quite sure you've noted we don't have the product price view. Okay. What I've just done is copied the name of the view we created earlier, this product information. We are going to highlight this, then click on execute. Okay. And you can expand this column. This now gives you the statements which were used to create this particular view. Let's move on. Creating a view using built-in functions. Now, when functions are used, the derived column must include the column name in the create view statement. Consider the view that was created in the following code snippet to make use of the average function. We are going to copy this. Okay. Now, if you look at this, I've made a change here. I've removed the underscore because if you look in your Object Explorer, we already have a view called VW product underscore details. So remove the underscore. You can write it as I have here, or you can just leave it exactly as it is in the slides. Highlight this, but make sure you remove the underscore. Highlight, then click on execute, and you can display the details by using a select star from this particular view. Okay, highlight this. Once you highlight, you can execute it, and it gives you the details of the items in this views base table. Okay, we move on. Check option. Now, the check option is used to enforce domain integrity, and it checks the definition of the view to see that the where clause conditions in the select statement are not violated. Sorry, the where condition in the select statement is not violated. The with check option clause forces all the modification statements executed against the view to follow the conditions set within the select statement. The syntax used to create a view using the check option is given below. Create view, then the name of the view, as select statements, and then the optional with check option. Now, where the with check option specifies that the modified data continues to satisfy the view definition. Now, the following code snippet recreates the product information view, and we want to ensure that the safety stock level should be less than or equal to 1000. Okay, highlight this, then copy, and let's meet in the query window. Now, we're not going to use our create statement. We want to modify. We have already created the product information view. What you're going to do is to use an alter statement. Make sure you change the create to alter. Okay, highlight this, then click execute. The view is modified accordingly. You can view the records which are now returned from this particular view. Okay, then we try to make changes which violate the check constraint or option. Okay, now the following code snippet, the update statement is used to modify the view by changing the value of the safety stock level column for product having an ID 321 to 2500. We are going to highlight this and execute, and you can see that the update statement fails to execute as it violates the view definition, which specifies that the safety stock level must be less than or equal to 1000. Thus, no rows are affected by the product info view. Now, on the other hand, ours is going to fail for a different reason. Remember, we don't have the modify permissions in the AdventureWorks database. Okay, so let's highlight this, copy, and meet in the query window. Now, we highlight this, click execute, and you can see what I was telling you. We don't have the update permissions in the AdventureWorks database, which is the database that contains the source or base table of this particular view. Okay, we move on. Schema binding option. Now, a view can be bound to the schema of the base table using the schema binding option. When the schema binding option is specified, the base table or tables cannot be modified that would affect the view definition. The view definition must be first modified or deleted to remove the dependencies on the table that is to be modified. And when the schema binding option when using the schema binding option in a view, you must specify the schema name along with the object name in the select statement. The syntax used to create a view with schema binding option is given below. Create view, then the view name with schema binding as the select statements, where view name specifies the name of the view, and the select statement basically are the statements which are going to be used to create that particular view. Okay, now I would like you to highlight this and copy, and let us meet in the query window. Now we highlight this set of statements, then click on execute. When we do this, this creates for us a view which is bound to the schema. Okay, we move right along. Now, using SP refresh view. Now, SP refresh view is a stored procedure, and it updates the metadata for the view. If this SP refresh view procedure is not executed, metadata of the view is not updated to reflect changes in the base table. This results in generation of unexpected results when the view is queried. The SP refresh view stored procedure returns code value 0 if the execution is successful, or it returns a non-zero number in case the execution has failed. What we are saying is like, you remember we made changes to the product details table, and if we didn't make corresponding changes to the view, then it would give us incorrect what? Results. That is why we use the SP refresh view stored procedure. Now, the following code snippet creates a table customers with the customer ID, the name, and the address columns. We have this. Then the following code snippet creates a view VW customers based on the customers table. We are going to do this after this, and basically we display all the records from this. The output will show 3 columns, that is the customer ID, the customer name, and the address. The following code snippet uses the alter table statement to add a column age to the table that we created, that is the customers. And then we can execute this again, and it's not going to reflect that. Now, the updated column age is not seen in the view, and to resolve this, the SP refresh view stored procedure must be executed on the VW customers view as shown in the following code snippet. When the select statement is run again, the age column is seen in the output. This is because the SP refresh view stored procedure refreshes the metadata for the VW customers view. Now, consider the schema-bound view that is dependent on the production.product table. The following code tries to modify the data of the product ID column in the production.product table from int to varchar. An error message is displayed as the table is schema-bound to the VW product info view and hence cannot be altered such that it violates the view definition of that the new product info view. Okay. Now we're going to copy these statements step by step, see what happens once you execute them. Okay. Now you're going to start by copying this, then you copy this, and you copy this, and you copy and paste. Okay. And finally, this should be the last one. Let's do this very quickly and let's meet in the query window. Now I've pasted everything and I've numbered this just so that we can get the flow. The first thing we're going to do is to create the customer table. We highlight this, execute, okay, that is created. We then create the customer view, come here, execute this. Then we display the details from the customer view, do that. Then we make changes to the customer table by adding the age, highlight this, then click on execute. Then we check if the customer view displays all the columns after the table's alteration. We highlight this, click on execute, and there is something missing here. Okay, that. Then after that, we execute this stored procedure. Now you can see here it's not giving us the age details. This is why we're executing the SP refresh view customer detail stored procedure. Okay. Then now if you execute this statement, it actually now gives us everything. Okay. We move right along. Stored procedures. Now a stored procedure is a group of TSQL statements which act as a single block of code that performs a specific task, and this block of code is identified by an assigned name and is stored in the database in a compiled form. A stored procedure may also be a reference to a .NET Framework Common Language Runtime method, and the stored procedures are useful when repetitive tasks have to be performed. Stored procedures can accept values in the form of input parameters and return output values as defined by the output parameters. The advantages of using stored procedures are given below. 1, they provide us with improved security, they have precompiled execution, and they also reduce the client-server traffic and enable reuse of code rather than having to write it every now and then. We have various types of stored procedures. SQL Server supports the following types of stored procedures. We have the user-defined stored procedures. User-defined stored procedures are also known as custom stored procedures. Okay, so please note that. Now these procedures are used for reusing TSQL statements for performing repetitive tasks, and there are 2 types of user-defined stored procedures. We have the TSQL stored procedures, and common language runtime stored procedures. Now, TSQL stored procedures consist of TSQL statements where the CLR stored procedures are based on the .NET framework common language runtime methods. Now, both the stored procedures can take and return user-defined parameters. We have the extended stored procedures. The work of extended stored procedures is to help SQL Server in interacting with the operating system. The extended stored procedures are not resident objects of SQL Server, and they are procedures that are implemented as DLLs, that is dynamic link libraries, executed outside the SQL Server environment. The application interacting with SQL Server calls the DLL at runtime, and the DLL is dynamically loaded and ran by SQL Server. SQL Server allots space to run the extended stored procedures, and extended stored procedures are usually prefixed with the letters XP. Tasks that are complicated and cannot be executed using TSQL statements are performed using the extended stored procedures. We have system stored procedures. Now, system stored procedures are commonly used for interacting with system tables and performing administrative tasks such as updating system tables. And the system stored procedures are prefixed with SP underscore, and these procedures are located in the resource database. Like you remember the SP refresh view, SP help text. These procedures can be seen in the C schema of every system and user-defined database. The system stored procedures allow, grant, deny, and revoke permissions, and a system stored procedure is a set of precompiled TSQL statements executed as a single unit. System stored procedures are used in database administrative and informational activities, and when referencing system stored procedures, the C schema identified is used. System stored procedures are owned by the database administrator. Classifications of stored procedures. Now, we're going to start here in the next session. So for this session, we are actually through, and let's meet in the next session. Nice time, God bless, and bye.